Hi everyone, today we are going to be solving Pearson Edexcel Chemistry Paper 1 Foundation Tier, June 2019. The three states of matter are solid, liquids and gases. What is the name of the change of state when a liquid changes into a solid? So a liquid changing into a solid is freezing. So C is the correct answer. Let's see the description of other states. Condensation is the process of a gas changing into a liquid. Evaporation is when a liquid changes into a gas. And melting is when a solid changes into a liquid. A gas was left to cool to form a liquid. Figure 1 shows how the temperature of the substance changed with time. Temperature. We can see the temperature drops from 100 degrees Celsius to 75 degrees Celsius, and then we can see a plateau. So since the starting material is a gas, so from A to B, it's a gas. And at 80 degrees Celsius, okay, let's see the division again carefully. Each division is 2.5. So at 77.5 degrees Celsius, it condenses. Wherever condensing occurs is also its boiling point. From C to D, it decreases in temperature as a liquid. So we can say from C to D, it's a liquid. From A to B, the substance is a gas. From C to D, the substance is a liquid. State the time when the gas first started to form a liquid. So the gas started to form a liquid at 2 minutes. Calculate the number of minutes it took from the gas first starting to form a liquid until the substance was completely liquid. So, to find out the time until it was completely liquid was 6 minutes. It started at 2 minutes. So, it will be 6 minus 2, 4 minutes. Figure 2 shows the melting points and boiling points of four substances, W, X, Y, and Z. So we can see W has a melting point of minus 220 and a boiling point of minus 188, whereas X it's minus 101 and boiling point is minus 34. Y, which has a melting point of minus 7 degrees Celsius and boils at 59 degrees Celsius. Whenever we have a boiling point which is lower than room temperature and which is higher than room temperature and melting point lower than room temperature, then it will be a liquid at room temperature. So just remember that this will be a liquid at room temperature and pressure. Z has a melting point of 114 degrees Celsius. Since 114 degrees Celsius is greater than room temperature, so it will not be a liquid at room temperature, it will rather be a solid. And it has a boiling point of 184 degrees Celsius. Give the letter for the substance that is a solid at 20 degrees Celsius. So solid at 20 degrees Celsius will be Z because melting point greater than room temperature. So it will be Z. Give the letter of the substance that is a liquid at 50 degrees Celsius. Substance Y is still a liquid at 50 degrees Celsius and it boils at 59. So substance Y will be the answer. The diagram below shows particles in 5 different structures. The different circles shows different particles. Draw one straight line from each substance to its structure. So, solid metal or zinc. So, solid metal, zinc can be substance which are in solid and closely packed and single element. So, this should be the correct answer. Hydrogen gas is an element but it consists of one single element, which is hydrogen. So it should be like this. So the one answer should be this one. Okay. Let's see why the other ones are not correct. First of all, this one represents a compound because we can see two types of atom chemically bonded together. This one is a mixture because it consists of two different types of atoms. And also it is in gaseous format. So they must be monoatomic elements. This one is also a mixture, which is a mixture of solid and looks like an alloy because particles of different sizes are mixed together. They are not chemically bounded. Alloys are a mixture of two or more metals. Alloy steels are formed when other metals are mixed with iron. Cutlery is made of stainless steel. Give 2 reasons why cutlery is made of stainless steel other than iron. So first of all, let's understand alloy. So alloy it can be a mixture of two metals, which gives it a different properties, which is not the same as the original metal that they came from. That means iron, which can rust very easily, when turned into stainless steel, will be able to resist corrosion. And also stainless steel is much stronger than iron. So iron is soft and stainless steel is stronger. So our answer should be in this way. Stainless steel does not rust/corrode. Stainless steel is stronger. Brass is an alloy of copper. Figure 3 shows the brass pins of an electric plug. So the brass pins, we can see, brass is harder than copper. Give a reason why using a harder substance for the pins is an advantage. The pins need to be sturdy so they do not bend. Magnesium is an alloy of magnesium and aluminium. It is often used for aircraft parts. Figure 4 shows information about pure aluminium and magnesium. Aluminium has a density of 2.7, whereas magnesium is much lighter than aluminium. Relative strength for aluminium is much lower, but magnesium has a much higher relative strength. Resisting corrosion for aluminium is quite high, but magnesium has a very high corrosion resistance. Explain using the information in figure 4 why magnesium rather than pure aluminium is used for aircraft parts. For using a particular metal to build aircraft parts, one of the important things that needs to be considered, because it's a particular device that we are going to fly around with, okay, is that it needs to be of low weight. Magnesium has lower density, so it requires lower weight or basically lower mass. It needs to be strong and it needs to resist corrosion from the weather. So the way we can write this answer is that magnesium has a lower density than aluminium. Then we can say magnesium is stronger than aluminium. And finally, we can make a comment, magnesium has a higher resistance to corrosion than aluminium. 63 grams of magnesium contains 3.15 grams of magnesium. Calculate the percentage by mass of magnesium in the magnesium. To find percentage by mass, we need to put 3.15 over the 63 grams of magnesium times 100. This will give us 5. So it will be 5.0. Transition metal and group 1 metals have many properties in common because they are all metals. However, some properties of transition metals are different from the properties of group 1 metals. So transition metals are known as the D block element, and the group 1 metals, they are known as the S block element. If we look into our periodic table is subdivided into S block followed by D block and then a P block. And you can see transition metal falls in the D block, which is a property of transition metals but not of group 1 metals. Both metals can be good conductor of electricity. So this is not a unique point. However, group 1 metals have low melting point, whereas transition metals have high melting point. So this can be a unique property of transition metal. Both metals are malleable, but group 1 metals are more malleable. So in terms of malleability, both malleable. Shiny when cut or polished. Every metal, when they are cut, freshly cut, or when they are polished, they are shiny. So this applies to both. However, unique properties of transition element is that they have high melting point. Copper is a transition metal. Magnesium reacts with copper sulfate solution to form copper and a solution of magnesium sulfate. So this description tells us that magnesium is more reactive, which is why it can displace the copper from its aqueous solution and form MgSO4 and release the copper as copper element. Magnesium sulfate solution is colorless. MgSO4 aqueous has no color, whereas CuSO4 aqueous has a blue color. Describe two changes when you would see during this reaction. This copper metal that is formed is a pinkish brown or red brown metal. So we can give two of the three following descriptions. The blue color fades and a colorless solution forms. Or number 2, we can say red-brown solid forms. And as a final point, we can say magnesium disappears. However, that's a third point and not very preferable. So the first two is much better. Rusting is the corrosion of iron. Water is one of the two substances needed for iron to rust. Give the name of other substance that is needed for iron to rust. So iron requires water and oxygen, both of them together in order to rust. By the way, guys, the word rusting is only applicable for iron, and it basically means iron 3 oxide but hydrated. That's why rust has a much higher mass compared to the iron that it comes from. The rate of rusting can be increased by using seawater. Describe a simple experiment to compare how much an iron nail rusts in seawater when compared to water. So the question asks us to describe a simple experiment. Even though simple, must be repeatable, and the description must include precise work. So the answer can be written in this way. Iron nails are cleaned, then they are placed into test tubes of water and seawater. The test tubes were left for a period of 1 week. Then the test tubes were observed and record any changes to compare the changes in their appearance. To get full marks, only 3 points will be necessary from the 4 points. Rusting can be prevented by galvanizing iron, which includes coating the iron with a layer of zinc. A small iron bucket was galvanized. The surface area of the bucket was 0.68 meters square. Calculate the mass of zinc required to coat the surface of the bucket with a layer of zinc of 200 gram per meter square. Since we are going to need 200 gram per meter square and our surface that we need to coat is 0.68, so we need to multiply both of them. This will give us 136 grams. Mixtures of substances can be separated using different techniques. Which of the following is a mixture of substances? So we know air consists of many types of gas molecules, mainly nitrogen, oxygen, argon, etc. Carbon dioxide is a pure element. Gold is just a pure element. Titanium is also a pure element. So you can see these three, they are pure. This one is a pure compound, and the other two are elements. So air will be a mixture of substance. Figure 5 shows the apparatus that a student set up to obtain pure water from ink. So the apparatus here that we can see is a distillation apparatus. There are 3 mistakes in the way the apparatus has been set up. One of the mistakes is mentioned. One mistake is the bulb of the thermometer is too low. The bulb of the thermometer should be level with the side arm. Give a reason why the bulb of the thermometer should be level with the side arm. The bulb should be, next to the side arm, so that we can measure the temperature of the gas that is passing into the condenser. So the answer can be written in this way. To measure the temperature of the water vapor passing into the condenser. State one other mistake in figure 5. The water out is in the wrong position where it should be water in, and the water out should be from here. So we can say the answer, the water flow in condenser is the wrong way around. Or we can say the beaker is not placed at the exit of the condenser. So droplets will fall other than the beaker. So it can be written as follows. Beaker not under the condenser exit. Paper chromatography is used to separate the substances in 5 different food colorings, P, Q, R, S, and T. The figure 6 shows the chromatogram at the end of the experiment. We can see the solvent front and the start line where P, Q, R, S, T were tested from. The steps needed to carry out the chromatography experiment are listed below. However, they are not in the correct order. Leave the solvent to rise up the paper. Put the solvent in the beaker. Draw a start line on the piece of paper. Place the paper in the beaker. Remove the paper when the solvent is near to the top. Put small spots of food colorings on the start line. The first 2 steps have been done for you. So 2 and 3 is the starting point. So 2 is our 1 and 3 is our 2. So put solvent in the beaker, draw a start line on the piece of paper. So the next one should be put small spots of food coloring on the start line. So the next one should be 6. Then we need to place the paper in the beaker. So number 4 is still number 4. Then we will have to leave the solvent to rise up the paper. So that's number 5. Then remove the paper when the solvent is near to the top. So that would be number 6. The 1 followed by 5. So if we put this entire statement in a chronological order, we see, so the first step is always putting the solvent in a beaker. Then the start line in a paper we need to draw. And after that, we need to put the spots of the food coloring at the start line. Then we will place the paper in a beaker, which will allow the solvent to rise, and remove the paper when the solvent is near to the top. This will be the general 6 steps of a chromatography. Because in the exam, this can come in any chronological order. So memorizing these statements would be, the steps of the statements would be much better than memorizing the steps with the number here. Explain using figure 6 which food coloring contains the greatest number of colored substances. To understand if it contains the greatest number of pigments or colored substances, we need to look for most number of spots. We can see in mixture T, there is a total of 5 spots, which is the greatest. So our answer will be mixture T because it has the greatest number of spots. During chromatography of food colorings, the solvent front moved 8 cm and the food coloring R moved 2.30 cm. Calculate the RF value of food coloring R. We have to give our answer to two significant figures. We know that RF is equals to distance that is moved by the food coloring R. So 2.30 over the distance moved by the solvent divided by 8.00, which gives us a value of 0.2875. Since our answer needs to be written in two significant figures, so it will be 0.29. The reactivity of copper, magnesium, and zinc was investigated. Each metal was placed separately in dilute hydrochloric acid. The amount of effervescence was observed. The same mass of metal was used in each experiment. Which piece of apparatus would be used to find the mass of metal used? To find a mass, we will definitely use a balance. So it can be a weighing scale or a top pen balance. Here the answer is balance. Now let's see the other options why they are not correct. A pipette is used to measure out a volume of liquid, a fixed volume of liquid. An example could be like 10 cm cubed or 25 cm cubed, etc. A stopwatch would definitely be used for finding time. A thermometer, on the other hand, would detect the change in temperature and give reading. State two variables apart from the mass of the metal that should be controlled in this investigation. Since this particular experiment is using acid, so two things for acid can be mentioned. First, volume, and the other one is concentration. Since we are using metal, that means the size of the metal will vary the rate of the experiment. So size of the pieces. Since the experiment is to find out rate of experiment, so temperature should be kept constant as well. So same starting temperature should be used. So the answer is same volume of acid or same concentration of acid, same size of metal pieces or same temperature. Magnesium produces the most vigorous effervescence. Copper does not produce any effervescence. This indicates that copper did not do any reaction. And magnesium produces most vigorous effervescence, meaning very reactive. Give the reason why copper does not produce any effervescence. So we can say copper is not reacting, or we can say copper is very unreactive. The magnesium reacts with dilute hydrochloric acid to form magnesium chloride solution and hydrogen gas. The equation for the reaction is magnesium reacting with hydrochloric acid produces magnesium chloride. Magnesium chloride is a soluble salt, so must be aqueous. Hydrogen, which is gaseous, so must be G in state symbols. The question asked us to fill in the state symbols, so we already did that. Now, with solubility questions, you need to know that all salts of potassium, sodium, ammonium, and nitrates are soluble. For the chloride, you also need to remember all salts of chloride are soluble except silver chloride and lead chloride. Potassium carbonate reacts with dilute sulfuric acid to form potassium sulfate. Potassium sulfate contains potassium ions and sulfate ions. Write the formula of potassium sulfate. So since potassium has only one plus charge and sulfate has 2 minus charge, we can write down their charges as numbers below them and then just switch their charges. So this would give us a formula K2SO4. Equal volumes of solution of potassium carbonate were reacted separately with an excess of dilute sulfuric acid. Pure dry samples of potassium sulfate were obtained from the resulting solutions. The experiment was repeated 3 times using the same condition, and the masses of potassium sulfate obtained were 5.22, 5.24, and 5.21. Calculate the mean mass of potassium sulfate obtained, giving your answer to 2 decimal places. To find the mean, we'll just have to add all of these masses and divide it by 3. We can give our answer to 2 decimal places only, so we'll write 5.22. Metals are extracted from substances naturally occurring in Earth's crust. These substances are generally known as ores. Which of these metal is usually found uncombined in Earth's crust? To get an uncombined metal, the metal has to be very unreactive. One of the most unreactive metal commonly known to man is gold. So gold will be the correct answer. In the reactivity series, gold lies at the bottom. One of the ways we can remember the reactivity series during our exam is by remembering the following mnemonic. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. So the P stands for potassium, the S stands for sodium, the K stands for calcium, M stands for magnesium, A stands for aluminium. The C here stands for carbon. Even though it is a nonmetal, however, it is reactive than most other metals, so it has to be placed in the reactivity series. Z stands for zinc. I stands for iron. Now here, the mnemonic is used according to what suits us. T stands for tin. L stands for lead. Tin has a symbol Sn. Lead has a symbol Pb. H stands for hydrogen. And copper is already mentioned, so the symbol is Cu. S stands for silver, which is Ag, and G stands for gold, which is Au. Zinc can be extracted by heating zinc oxide with carbon. The products are zinc and carbon dioxide. Write the word equation for this reaction. So, to write a word equation is very easy. We just need to follow the statements. So, the reactants are zinc oxide and carbon. So, we will put them with a plus and write them on the left. And the products are zinc and carbon dioxide. In this reaction, zinc oxide loses oxygen. Loss of oxygen is regarded as reduction. State the type of reaction taking place when an oxide loses oxygen. So the type of reaction will be reduction. Aluminium is extracted from aluminium oxide by electrolysis. Aluminium oxide is made up of ions. The formula for aluminium oxide is Al2O3. Give the number of ions in the formula. So aluminium oxide consists of 2 aluminium 3 plus ions and 3 O2 minus ions. This makes a total of 5 ions. So the answer will be 5. Complete the balance equation for the overall reaction by putting numbers in the spaces. 2Al2O3 is being broken down to aluminium. Since we have a 2 in front of the Al2, so 2 times 2 produces 4. The 2 times 3 produces 6 for the oxygen. So 4 aluminium. Okay, now oxygen comes as a diatomic. So there are 2 atoms every time with it joined together. So 6 atoms will produce 6 divided by 2, 3 molecules. So we'll say 3O2. So 4 aluminium and 3 oxygen. The environmental impact of a product is assessed in a life cycle assessment. The stages in this assessment are given below. They are not in the correct order. Disposal of the product, manufacturing of the product, obtaining and processing the raw materials, using the product. List the stages of life cycle assessment using A, B, C, D in the correct order from start to finish. So first of all, in order to produce any material, we need to obtain the raw material and process the raw material first. Then we need to manufacture the product in order for it to be used. So the next step will be using. And finally, in the life cycle assessment, we need to think of how we are going to dispose of the product or recycle the product. Aluminium can be obtained by recycling aluminium waste. Give 2 advantages of obtaining aluminium by recycling aluminium waste. Rather than mining the raw material and extracting aluminium from that raw material. So, we can recycle aluminium waste and get the metal, meaning no need to tap into the finite resource of the ore. We can say conserves ore. That can be one of the points. Now the question says give 2 advantage of obtaining aluminium by recycling aluminium waste. Generally, when obtaining aluminium from ores, we need to do electrolysis. So no need to do electrolysis for recycling. Electrolysis is a very energy intensive process. So the answers can be written in this way. It conserves the natural reserve of the ore, or we can just simply say it conserves the aluminium ore. The second point is we can say less damage to the landscape because we are not going to dig up the ore from the land, and that typically saves habitats. Other than that, alternative points can be less electricity or energy is required to process the aluminium waste compared to extracting it from its ore, or we can say less waste metal goes into the landfill because we are recycling it. So these are the 4 points that we can write. Now, 2 of them is needed for your exam. Just choose any 2 that you like and give it in your answer. Fertilizers contain compounds that promote plant growth. State the name of an element in this compound that promotes plant growth. So plant growth is mainly, plant growth increases by certain compounds such as NPK. NPK stands for nitrogen, phosphorus, or potassium. So all of the 3 will be correct. Potassium nitrate is present in some fertilizers. Potassium nitrate is formed by the reaction of potassium hydroxide solution with nitric acid. Complete the balanced equation for this reaction. Potassium hydroxide, when it reacts with nitric acid, it produces potassium nitrate and water. In the Haber process, hydrogen and nitrogen react to form ammonia. When hydrogen reacts with nitrogen, it produces ammonia. Ammonia has a formula of NH3, nitrogen is N2, and hydrogen is H2. So, 3 hydrogen is required with 1 nitrogen molecule to give 2 molecules of ammonia. The symbol in the word equation shows the reaction goes forward and backward at the same time. Give the name of the type of the reaction. So this symbol represents that the reaction is reversible. State the formula of a molecule of ammonia. Ammonia has the formula NH3. So technically we'll have to memorize the formula. Ammonia is NH3. Figure 7 shows a graph of world ammonia production in millions of tons from 1945 to 2015. You can see world ammonia production from 1945 has increased and then decreased slightly before increasing again from 1995 to 2015. So there is an overall increase we can see in the graph. State the overall trend in the world ammonia production between 1945 to 2015. So the world ammonium production increases over time. Hydrogen can also be used in hydrogen-oxygen fuel cell. Give the name of the product formed in this fuel cell. So, in the hydrogen-oxygen fuel cell, the hydrogen reacts with oxygen. So, this gives us a product of water. The balanced chemical equation includes 2 hydrogen reacting with 1 oxygen to produce 2 water. So we'll just simply state the name of the product, water here. This question has an asterisk, meaning that we will have to give the answer directly from our syllabus. Ammonia solution and dilute sulfuric acid are used to prepare dry ammonium sulfate crystals. In an experiment, a titration is carried out to determine the volume of ammonia solution and dilute sulfuric acid that react together. So our experiment has been done where we were doing titration, and ammonia, which is the base, reacting with the sulfuric acid, which is the acid, alright, and we need to determine their volume. Then an ammonium sulfate solution is prepared from which the pure dry crystals are obtained. Describe in detail using suitable apparatus how this experiment should be carried out. So this particular experiment should involve the steps of titration. Now titration includes indicator, which creates impure salt. So followed by titration, a repeat of the same volume. Repeat, but this time no indicator should be used. And after that, the solution that is received, the solution should be evaporated and followed by dry crystals obtaining. The answer can be written as follows. Use a pipette to measure out 25 cm cube of ammonia solution into a conical flask. Then add an indicator such as methyl orange. Now guys, there is a note here. The note is weak base versus strong acid. We cannot use phenolphthalein as an indicator. So methyl orange should be used as an indicator. Then put the flask in a white tile. Fill the burette with dilute sulfuric acid solution. Take a reading before and at the end of the titration from the burette. Repeat the experiment until concordant results forms. With the concordant result, then mix the same volume of sulfuric acid and ammonia solution without the indicator because we're trying to obtain a pure solution. Then pour the solution into an evaporating dish and heat the solution to the point of crystallization. Once it is heated to the point of crystallization, then we can leave the solution to cool so that crystals can form. Those crystals are then filtered off. Then leave those crystals in hot oven in a filter paper to dry. In figure 8, the letter A, E, G, X, and Z shows the positions of 6 elements in the periodic table. These letters are not the symbol of the atoms of these elements. So from the periodic table, if we place them side by side. A in this case is representing lithium, J is representing sodium, E is representing boron, G is representing oxygen, X is representing argon, and Z is representing iron. Now, the way I did it is I placed the periodic table in the same place and looked up the position, and I determined what element they are. Using the letters A, E, G, J, X, and Z, give the letters of the two elements that are nonmetals. Nonmetals are found in the right side of the periodic table. So they must be G and X or even E. Now, since they asked us two elements only, so you have to mention any two. Give the letters of the two elements in period 2. Period 2 refers to a horizontal line. Now, period 2 indicates two shells. So that should be this one. So A, E, and G. Since the question is asking for two elements, so any two. Give the letter of an element that normally forms an ion with +1 charge. +1 charge is formed by group 1. In the periodic table, the group 1 element is A and also J. Element E has an atomic number of 5. In a sample of E, there are two isotopes. One isotope has a mass number of 10 and the other isotope has a mass number of 11. Explain in terms of subatomic particle what is meant by the term isotopes. Since we know the definition by heart, is that atoms with the same number of protons and different number of neutrons are called isotopes. Now, another way we can find out the same answer is that they both had the same atomic number. So, this means same number of protons. And they had a different mass number, which can indicate that the number of neutrons are different easily. So, the answer will be atoms with the same number of protons but different number of neutrons. All atoms of element E in this sample contain, so since this is the same element, they must have same number of protons, which in this case is 5. Element X has an atomic number of 18. State the electronic configuration of element X. So element X has 2-8-8 configuration. The standard way of writing can be 2.8.8. In an experiment, 3.5 gram of element A reacted with 4 gram of element G to form a compound. Calculate the empirical formula of this compound. The relative atomic masses of A and G are given below. So, with A and G, we are going to write down the amount that they are reacting with. Then we will divide their mass by their relative atomic mass. So 3.5 will be divided by 7 and 4.0 will be divided by 16. This gives us their number of moles, which is 0.5 and 0.25. Now, their number of moles needs to be simplified. So the next step will be to get the simplest ratio, we will divide them with the smaller of the two numbers, which is 0.25. This gives us a 2:1 ratio. So, empirical formula A2G. An oxygen atom has 6 electrons in the outer shell. A hydrogen atom has 1 electron in the outer shell. Complete the dot and cross diagram for a molecule of water. So, according to the description, oxygen having 6 electrons in the outer shell, and hydrogen has only 1 electron in the outer shell. So to complete this diagram, we'll draw the electron for the hydrogen and then we'll complete the electron for the oxygen. We already have 2 crosses, so 4 more needed. Water acidified with sulfuric acid is decomposed by electrolysis. The water is decomposed to produce hydrogen and oxygen. A sample of hydrogen is mixed with air and ignited. State what would happen. Hydrogen reacts very fast with oxygen in the air. So, it will lead to a violent reaction, which we can say squeaky pop, or we can say water forms. Whichever is convenient for you, you should write that one. Throughout the experiment, the volume of hydrogen and the volume of oxygen was measured at 2-minute interval. The results are shown in figure 9. Time in minutes, 0, volume of oxygen, hydrogen and oxygen. As the time continues to 8 minutes, volume of hydrogen is 16 and volume of oxygen is 8 cm3 respectively. Describe using the data in figure 9 what the results show about the volumes of hydrogen and oxygen produced. First thing we can tell that they have a ratio of their volume with hydrogen ratio oxygen, hydrogen having 2:1. Now, we can give the description in this following way. The volume is going up for both oxygen and hydrogen with time. So volume is directly proportional to time. The other one we can say the volume of hydrogen is double the volume of oxygen. So it's in a 2:1 ratio. Molten lead bromide is electrolyzed. The product of this electrolysis are, now if we look into molten lead bromide, we have PbBr2. Now if you do not remember the formula, it's still fine. We just need to know that what type of compounds we're going to get from it. Of course, since it is molten, so we can only get the metal and the bromine. So when the answer says hydrogen, it's definitely wrong. The answer saying oxygen is also wrong. So lead and bromine. Calcium nitrate and calcium carbonate are both ionic compounds. Calcium nitrate mixed with water behaves as an electrolyte. Calcium carbonate mixed with water does not behave as an electrolyte. Now, guys, as stated in the earlier part of the question paper, all nitrates are soluble. So mixed with water behaves as an electrolyte. Now, calcium carbonate, carbonates are insoluble, specifically calcium carbonate. So insoluble, meaning it's not going to give those ions, which is going to act as an electrolyte. The question says, explain in terms of solubility and movement of ions these differences in behavior. So the answer is calcium nitrate is soluble, but calcium carbonate is insoluble. So in calcium nitrate, the ions are free to move in solution. Impure copper can be purified using electrolysis. In this electrolysis, the anode is made of impure copper. The cathode is made of pure copper. The electrolyte is a copper sulfate solution. The apparatus at the start of the experiment is shown in figure 10. So, since the left side is the cathode, so that is the negative pole, and the right side is the anode, so that must be the positive pole. During electrolysis, three observations are made. The size of both the anode and the cathode changes. Solid appears directly beneath the anode. The color of the copper sulfate solution does not change. Explain all three observations. So in general, both anode and cathode changes because impure copper turns into copper 2 plus ions, goes into the solution and get deposited as copper metal in the cathode. So the size should increase, and whereas the size in here should decrease over time. Since there are impurities in the anode, so impurities will fall at the bottom as sludge. Now, the copper sulfate solution is not affected because if one copper ion is generated, that copper gets deposited in the cathode. So, the copper 2 plus solution, the copper sulfate solution, the copper 2 plus ion concentration do not change. So, solid appears beneath the anode or impurities, and the concentration of copper plus ion does not change, which is why the color of the solution does not change. Since this is a asterisk question, we'll have to give the answer directly from the syllabus. So the answer can be written as follows. Copper atom forms copper ions at the anode. So copper turns into Cu2 plus and gives off 2 electrons. The copper ions are then attracted by the cathode. The copper ions gains electron at the cathode to form copper atoms and get deposited. So Cu2 plus from the aqueous solution gains 2 electrons to form copper solid. The color of the solution remains same since for every copper ions entering the solution at the anode, one is removed from the solution at the cathode, and the solid below the anode are insoluble impurities falling from the anode. Calcium carbonate decomposes on heating to form calcium oxide and carbon dioxide. Calcium carbonate forming calcium oxide and carbon dioxide. Now the question says 8 grams of calcium carbonate was heated strongly for about 10 minutes. 6.213 grams of solid remained. Calculate the mass of carbon dioxide given off. So the mass will be 8 grams minus 6.213 grams equals to 1.787 grams of carbon dioxide. A second sample of calcium carbonate is strongly heated in a crucible until there is no further loss in mass. The mass of the calcium oxide remaining in the crucible is 5.450 grams. The theoretical yield of calcium oxide in this experiment is 5.600 grams. Calculate the percentage yield of calcium oxide. So, the mass of the calcium oxide that is remaining in the crucible is 5.45. Now, what we're supposed to get was 5.6. To get a percentage yield, we will put the mass that we have obtained over the mass that we are supposed to get times 100. This gives us 97.3214, and since our percentage yield needs to be a 3 significant figure, so 97.3. The mass of the solid left in the crucible is less than the theoretical mass of calcium oxide that should be obtained. A possible reason for that is, now we have lost some mass. So the possible reasons are that are given. Some solid was lost from the crucible. Yeah, so we can lose some solid from the crucible, maybe due to a particular process called spitting, where basically when the CO2 was being formed, it basically flickered the solid out from the solution, from the mass. The solid remaining absorbed some water from the air. Now, if it would absorb some water from the air, it would increase in mass. Some carbon dioxide remained in the crucible. This would also cause the mass to increase. The decomposition was incomplete. This would also cause the mass to be higher. So all the other three causes mass to be higher than theoretical. Another sample of calcium carbonate is heated and the mass of solid remaining is measured each minute. The results are shown in figure 11. We can see from 0 to 7, it changes in mass from 9 gram to 5.2 grams. Explain the trend shown by the data in figure 11. So since our question is asking for an explanation, we can see initially the mass lost was 0.9 gram in 1 minute. Whereas in the last minute, the mass lost was only 0.1 gram. So the rate of mass loss is slowing down as the amount of reactant decreases. It is impossible to be sure from this data that the reaction is complete. State why. Because we did not receive a fixed mass which does not change. So our answer can be written. The mass may decrease further because it is not heated to constant mass. So any one of the 2 points can be written. Calculate the relative formula mass of calcium carbonate. So relative formula mass MrCaCO3 can be calculated. Calcium having the value 40 plus carbon, which is 12, plus 3 oxygen, 16 times 3 gives us 100. Calculate the atom economy for the formation of calcium oxide in this reaction. Now, calcium oxide is our desired product. Since we do not want the carbon dioxide, that is our byproduct. So, atom economy is calculated based on desired product. Percentage atom economy equals to mass of calcium oxide, which is 56, over 100 times 100 will give us 56% atom economy. So guys, that's the end of this particular question paper. Thank you for watching this particular video. Guys, question paper videos like this will be uploaded almost every day. So please subscribe to the channel and definitely your question paper will also be uploaded. Alright guys, see you in the next video. Best of luck for your exam. Bye-bye.